Aerospace is about reaching further in technology, into space, and into the future. You want to reach further too. You enjoy puzzling, prototyping, and pioneering. You're drawn to complex questions behind how to make aviation and space travel ready for tomorrow. Quieter, safer, faster, and cleaner. You'll join a community of students from all over the world who, just like you, get bright-eyed over anything that flies. Being part of such a diverse international group prepares you for the aerospace world from day one. This industry revolves around teamwork and a global point of view. That's why it's such an advantage when you've already worked during your studies with people from different cultures, with different perspectives, norms, and values. In our hangar and labs, and on site with partner companies, you will work on technological innovation that reaches past aerospace itself. From developing satellites to improving wind turbines and Formula One materials. That's how you grow into an engineer who helps technology reach further.
Applied Aerospace Live.
Hi, good afternoon, ladies and gentlemen. Welcome to Applied Aerospace Live. This is the 10th episode of Season 1, where we cover the Artemis 2 mission. My name is Erik Laan. I'm a lecturer of space engineering here at Inholland University of Applied Science. And I'm very honored and happy that I have as a co-host today my good friend Jan Persson from the European Space Agency. Jan, please introduce us. What's your role at the agency?
Thank you for inviting me, Erik. Like you say, we know each other. It goes quite some time back to the ISU, International Space University. And my role, I work for the European Space Agency at ESTEC in Noordwijk. I'm part there of the team working on Gateway. That is part of the plans for Artemis, or it has been part of the plans for Artemis by having an outpost in an orbit around the moon. And I support the team. I'm part of the team, I should say, being the lead engineer for the space segment.
Yeah, that's an interesting project. So we might have a discussion later on that. But we know each other from the ISU, International Space University. I went there in 1998. We had also Bram van Hemmen here in the one episode, a few episodes back. He went to ISU 2 years ago, and you went in.
I'm really a veteran then. Yeah. I went in 1992.
1992, okay, a real dinosaur in the room here. Yes. Now, ISU is a great place for spending a good summer on space stuff. But one of the reasons we invited you over, because you actually joined the launch of the SLS. Like it's 11 days now ago that they launched, and I can already tell you, well, there is a good splashdown last night, so we are very happy that the astronauts are safely back on Earth. But you actually went to the launch 11 days ago.
Yes,
and you brought a lot of stickers and stuff.
1st of April.
Yeah. So tell us how did you experience the launch?
Yeah, I have been to launches in the past, also to a shuttle launch. Back when the element I used to work on for the ISS, one of the nodes was launched. And this time it was, of course, with the SLS rocket. It's a rocket that builds on what was used technology from the space shuttle. But it's even more powerful. So I recognized the launch, how
It was more powerful to feel.
It was
the
more
launch.
powerful. Of course, what you have when it lifts off is the effect from the boosters mainly. They give the most noise. It's really physical. You feel the vibrations that are generated.
In your chest.
With a delay, because you're not too close. You can see it here. On the picture, I was in a place called Banana Creek with my ESA cap on. I can tell you it was a lot about NASA during the launch.
You brought a bag full of goodies from the launch.
And so you have a delay. You see it take off the rocket, and you have the blinding light, especially from the boosters, and then it takes quite a few seconds before you hear really how there is the rumble from the rocket.
The rumble, the rattle. So I was wondering, is that the rattle from the solid rocket boosters?
Yes.
Yes. So it's not like the RS-25 engines.
No.
Those are more, how to call that, more silent.
That's a difference. I think also if you compare with other rockets that you have.
Yeah, so that was quite a treat that you got there from the launch. Also that it was actually perfectly on time. They didn't expect the astronauts. They told in space that they were like, okay, we are prepared to launch, but we didn't expect that it would be like really at the start of the launch window. And they would say, well, maybe we have 1 hour to wait for something to get fixed, but it all went very smoothly.
It was the third launch window that they had, of course. It was anticipated earlier in the year, but now for this launch window, it was right on time on the opening of the launch window that it took off.
And so they went to the moon, they flew around, and last night they came actually back. So last night I put my alarm clock at 1:45. So I had to look at the last parts of the landing, which were very, very nervous-wracking, I should say. I'm really happy that they made a safe splashdown, and we have some movies from last night, which starts with this beautiful segment, I think, looking from the solar panels built by Airbus in Leiden. Looking at the European Service Module and also, of course, the beautiful Earth in the background. And so this you see actually over time that it moves. This Earth, it gets closer and closer. And at some point they are going to separate these two. We have had these things on the table for all the episodes. So we have the European Service Module on one side, and what we call the Orion capsule.
The
integrity,
the command module.
The command module. So the whole thing, how do we call that actually? Is that the Orion?
That's the Orion vehicle.
And so this is the European Service Module, and this is the Orion capsule. And at some point they separate because they don't want to drag this thing along. So they separate it. And it's a quite interesting segment in the movie where
it also protects the heat shield, of course, which is very important for the re-entry.
That was the critical item last night, that the heat shield should do what it's supposed to do, protect the astronauts. And here we see actually happening the separation between the two. There is this interesting interface where the power is given to the capsule, but then the capsule is all by itself after the separation. And so, they are separately actually re-entering, where the capsule should survive, but the European Service Module basically gets destroyed in the atmosphere.
Yes, it burns on re-entry. It has no heat shield.
Yeah, nothing left of it anymore, and it completely gets destroyed.
It's a good question. I don't think there is anything reaching the surface.
Yeah, yeah. Sometimes with these cylinders, the tanks, they sometimes.
Yeah.
Actually, here we look at the entry. So this is a camera looking backwards from the capsule. So the capsule is now flying with heat shield forward into the atmosphere. We see the plasma starting, and then after they hit the entry point, it's about 10 seconds, and there is a blackout.
Yeah.
And we'll witness this blackout in a few seconds from now. We see the plasma tail on the backside, and then poof, we are now 6 minutes blackout, and this is the scary moment. And this is where we have no visuals. We don't know what's going on. We only know those 4 astronauts are in there.
You have to rely on the heat shield doing its work.
Yeah,
yes.
yeah. Yeah, and this was the nerve-wracking moment for people watching, and I'm sure for the astronauts on board that were also a bit like, okay, let's wait and see. What else can you do when you are on board, of course? Yeah, and luckily, it was again perfectly on time. They asked, well, integrity. This is command. What's your status? Yeah, we are back exactly on time.
Absolutely, and it was because experience from Artemis 1, the unmanned test flight that took place. Also, something I understood, they had changed the entry trajectory in order to avoid some unforeseen erosion that took place on this ablative heat shield during the Artemis 1 mission. We have to see if they have analyzed that later, of course. Yeah. But we know that it worked like it should.
Yeah, I'm curious to the pictures. We've seen the Artemis 1 heat shield pictures where you see really the streaks and the parts of the heat shield fallen off basically. And now, I look forward to the images as a comparison between the two heat shields. So let's go to the next segment of this movie. So after the blackout, the capsule is flying, and there is I believe some back panel on the capsule that gets thrown off, which you see here, and then there is 2 drogue parachutes for further deceleration.
And also for stabilization, I think, of the capsule.
Yeah, so it doesn't start to tumble around, and because this is not yet really the real parachutes. We're going to see them after this segment. That these drogue chutes do their work for some altitude level, and then there will be the main chutes, and it will be the next segment. So these drogue chutes also get thrown off the vehicle, and then we see first 3 small parachutes, basically pulling out 3 big parachutes. That's how it works.
Yeah, it's a staged approach. And of course, much like I think we know it from Apollo in the past.
Yeah, we discussed this before. This is actually very similar to what they did on Apollo. And I had already this morning discussion.
Here we see one taking more time to deploy one of them, but finally it does.
Yeah, and look at the amount of fabric. That was a discussion at home this morning, where it was asked, well, how can you pack so much fabric into the small capsule? Is it not half the size of the capsule? So much fabric. Of course, it's a very lightweight.
And it's important, anyone being a parachute jumper will know that it's very important how you pack that.
How you pack it, yes. Yeah. Also, this is interesting. When the parachutes were deployed, and this is an thermal infrared camera looking at the capsule, and you see that there is some fending off of gases on the capsule, that there is plumes of gas coming from the capsule, and assuming it is hydrogen.
Yeah, I
or
imagine
other gases that they get rid of before the touchdown.
I think combustible gases which they have no use of any longer. They release.
Yeah, all to be safe when the splashdown happens. That there is no hazard from all these combustibles around the capsule when it's floating in the water. And then there is at some point the splashdown, and that's the next segment where you see actually the touching of the water by the capsule, and then the parachutes, they fall into the ocean, and at some point I think also they cut the parachutes because I believe there is some risk. That one of those parachutes basically gets underwater and it gets filled and then drags the capsule down. Look, here they separate.
You're right.
By some cutting mechanism. But I mean, this cutting mechanism is such an important mechanism. It should not work when it's actually flying, but it should work at this moment. And those are always the mechanisms that are the most tricky. That have a critical function, and how do you design them? I mean, that's all the technical people that think about all those mechanisms.
You have to have the right inhibits in place that you don't by accident activate it.
So the crew is basically safe now. So this was also the moment for me to start sleeping again. So this is what I watched this morning. So they release the crew from the capsule and they load them onto like a little, how do you call it? Little boat, but it's not really a boat.
A raft?
A raft, yeah, that's a good word. But I found there's so many people on the raft. I was thinking, well, how do you prevent people from not falling off the raft? And it looked a bit, clumsy, maybe from the first perspective.
Of course, here the sea is calm.
Exactly.
If there would have been more waves. Could be more tricky. We see here the 4 astronauts sitting on one side of the raft. Basically they just came from 11 days of microgravity. They flew to the moon and back, but they experienced no forces on their body. Only in the beginning a lot, but and the end
a lot. And now they're like kind of maybe exhausted from that trip. But so they came out in the raft, and then they were picked up by 2 helicopters and put on the deck of a marine vessel. And here we see one of the astronauts walking from his helicopter to the medical examination. So they check these astronauts for medical stuff. You look, the astronauts is a bit wobbly, I think.
Yeah, stiff legs.
Stiff legs. Is that something that astronauts tell about the first time they walk again? Do you know that?
Well, you have of course those who have been for like a year on board ISS. That's a different story. Here they were gone for 10 days. So they should not have too much effect from it. I don't know. It's also a bit how much they are hampered, but by what they are wearing. I don't know. So actually we looked at the splashdown, and it was very similar to Apollo. We have also watched here a little movie from Apollo 15. This is like 56 years ago. And it looked very, very similar to what we saw last night, and also how they extracted the astronauts, not with the raft, but with more of a speedboat. They took away the astronauts, and they put also the astronauts in some kind of cage, and then they lifted them to the helicopter. But for the rest, it was a very similar event, I think. Same type of approach.
But Orion is one size bigger than Apollo. If you compare the two, It looks very similar, but actually Orion is almost 2 times more more in diameter. So yeah, but it's interesting to look at those things from the past, that we still do it like they did it in the 60s and the 70s.
Yeah, if what works, I think that's a good way. Don't change the winning team. If it was tested and tried in the past. Don't experiment too much.
No, but I know, for example, with the Crew Dragon, so that's the capsule they use for bringing astronauts to the International Space Station, and that also comes back, and they kind of live that on board of a vessel, and there is no like rafts around it and divers, but it's like the whole capsule gets...
True. Of course, that is also, how to say, more that they do it very frequently. So maybe they develop more equipment around it. Yeah, that's true. Yeah, so that's this is like the first time basically they are doing this. So we might see in the future when they, for Artemis 25 and 26, they have maybe more advanced tools to do that. Yeah, so we've now looked at this whole saga of Artemis 2, and I think it was a very interesting experience. Also for broadcasting these from Inholland and having all the guests around, and now concluding this this whole event for Artemis 2, and we continue to watch it. Maybe some last remarks is that we have on Wednesday, we have a big party here called Yuri's Night, and we've been to Yuri's Night in the past, I think. It's been around for a long time.
Been around for a long time. And I've got, yesterday I got the nice stickers to give out at all the participants on Wednesday. But also we've got from you some back with some goodies from the Artemis 2 launch. And we'll do a number of games on Wednesday where, we will have what you brought for us will be the prizes for the Yuri's Night competition that we will have on Wednesday. So thank you for that, Janne.
You're welcome.
And it was a pleasure to have you with us here, and to conclude this whole saga with us together. Looking back also at the launch that you were there, and now with the nice splashdown. I believe we also have some questions. So feel free to ask some questions in the chat. We will try to answer them. So there is a question: why was the capsule hanging at an angle from the parachutes?
That's a good question. I don't know what the winds were during the descent, but also it has to do with the center of gravity of the capsule. It should be fairly much in the center, but those are the parameters which will play a role in that case.
And also you have to design it at some point, and maybe there was, this is where we have the most room to put like the connection point, and there is other systems in the way there. But I think the center of gravity, and to prevent the capsule from like swinging too much or tumbling around, you want to stabilize it. That's what you want to do. Maybe that's the most stable position for the capsule.
I don't know if you do anything here at the school with parachutes.
Actually, yes. Well, we have our Aquilo rocket team, who are launching in May their 9th rocket, and it goes to 3 kilometers altitude, and they also come back with parachutes. So we know a little bit of about parachutes here. Okay, there is a next question. Did the capsule before re-entry first bounce off the atmosphere to slow down? Is this manually piloted or by a computer?
It's a kind of strategy that you can use to slow down a vehicle before re-entry, but it means that you have to make another orbit, of course. For Mars entries, it has been used in the past.
So that you dip into the atmosphere to lose speed, and you go out again, and the next orbit you do it again and again and again, and then
to slow down.
But they did it again, right? Like with Artemis 1, they did it, and now with Artemis 2, they also did it, but in a different...
They did, it was a direct re-entry, it was not bouncing.
It was
first.
not bouncing,
no.
Okay. Yeah.
No, I have to say I have not worked directly with the Artemis 2 mission. I have been my background is thermal engineering, and when there were design reviews for the European service module more than 10 years ago, because it's been a long development, I was part of that.
Okay, so well then you did actually...
Yeah, so in a way I have contributed in that way, but not for the specific Artemis 2 mission.
No, and for the like the mission itself. Like,
for the design of the European service module.
Okay, why was such a complex helicopter operation necessary to retrieve the astronauts? Could it not be done with a boat with a low platform? Well, this was exactly my question.
Yeah,
and I would agree with this is a complex operation with the raft and the divers and the helicopters, and yeah, why not use some kind of vessel where you just dock with the capsule and you can take them directly on board instead of this whole... Yeah, but like we said, this might be coming if they fly more frequently, because you need a special vessel for it, and it costs money.
Exactly. I think if Orion continues flying on a regular basis, they would consider something like that.
Yeah. So now the astronauts are back. What mission-related things will they be doing the next few days?
They will undergo medical examination. That's what I know.
Yeah.
And I don't know if there will be any ticket tape parade.
Like in the, yeah, that's I don't know if they're welcome to come to Inholland. We'll give them a ticker tape parade. So this is an invitation for astronauts listening in.
But there will be plenty of post-mission evaluations, I'm sure. Also from European side with how the service module was doing.
Yeah.
But from what I know, it worked perfectly.
Yeah, actually, during the flight, just before the last burn of the European service module, it had to be used to make a final burn for targeting. And actually, the mission commander, Reed Wiseman, said, well, thank you to the Airbus team and the ESA team in the Netherlands, in Germany, for all your perfect work, because you made such a beautiful vehicle. So there was a nice shout out to...
And the mission control for that part was in Noordwijk. They have a special room there where they follow the service module during the mission.
Okay, yeah. Is that in
the Erasmus
building? Erasmus building,
yes.
Okay, yeah. Oh, we should do a tour there one day.
I've been there. It's nice.
How do they achieve such precise landing targeting given variables like weather and atmospheric conditions? Yeah, that's a good question.
Yeah, because they could predict very well the splashdown. Yeah, they had the experience from Artemis 1, of course. But it's a lot of simulation, I would say, because they have to know the atmospheric conditions quite well.
Yeah, but I mean, they do some, the capsule needs to be in a certain orientation during the re-entry, and they need to keep that orientation. And so what kind of controls do they use? Is it some thruster or is reaction wheels that they keep the orientation, or is it a passive? That it always gets in a passive way to its re-entry configuration.
It's not like the space shuttle that they could use flaps or anything, and that you can anyway only do when you have reached a certain flight regime. So I think this was purely ballistic.
Purely ballistic, yeah. So no active control.
No.
Yeah. So what they did, I believe the answer to this question is then, so they look at the weather at a certain time, and they predict the weather for the splashdown moment, and then they start to calculate. Okay, what does it mean for where Orion is flying now, and we have to do like a final burn using the latest data on weather prediction to do what kind of burn do we need to be exactly in a point given the prediction of the weather. That's I believe what they do, because if it's pure ballistic, then they just they fall and they don't do anything with changing weather or and also not in the final descent. This is all purely passive, right? The parachutes are there and they just it takes them where the wind takes them.
If there would be strong winds, it would drift off to some extent, but that's accounted for.
Yeah. Right, questions keep coming in. Don't forget to mention Career Connect, upcoming Tuesday, Arnold, at 1 o'clock. Yeah, we have many aerospace companies coming on Tuesday, because our students are always looking for internships, and we also look for projects that we can do together with companies, and also with ESTEC we did once a project. Yeah, so they're all coming here on Tuesday for Career Connect. So all students listening in, please come over to the terminal and meet all these great companies. And similar for Wednesday, of course, we have the Uri's Night party. Make sure to register if you want pizza, because that's what we have. We want you to register so you can enjoy the pizza together with us. Thank you, Arnold, for reminding us. We have one more question. Is this the last episode, and are there coming more episodes about different topics, and when? Well, yeah, this is, I would say, the last episode of season 1, and season 1 I call Artemis 2, and season 2 will be coming. We'll be, of course, looking at other space missions, but we also have lots of things going on in this building, the terminal, where we work with students in companies on projects. We work on Inholland Sat1, our own satellite. We work on Dragonfly, electrifying aircraft. So we've got lots of stuff going on, and we will do Applied Aerospace Live in the near future, and we will have many interesting aerospace topics to show the world.
Let's see Artemis 3.
Artemis 3, yeah.
NASA has ambitious plans now, accelerating the schedule.
There's already next year Artemis 3, and Artemis 4 and 5 in 2028.
That would be the actual landing, I think.
Yeah, the actual landing. Yeah,
we'll have to see.
We'll sure be here. Yeah. So thank you, Janne, for joining us. This was episode 10 of Applied Aerospace Live, the final episode of season 1, and look forward to seeing you for season 2. May the force be with you. Okay. Dankjewel.
Thank you.